Hello everyone, welcome to the video lecture series of C programming language. We are in our lecture number 53. From this lecture onwards, let us start learning about structures concept in our C programming language. So what actually a structure is? Structure is nothing but normally if you take an array, with arrays we have an option of storing only the values of same data type, where a variable will be holding only one value. But if you want to hold multiple values, we can go with the arrays concept, where arrays allow us to store more than one value. But the problem here is all the values should be of same data type. But in real-time scenarios, sometimes we want to have an option of storing multiple values of different data types. Let us consider a student database where we want to store student data, which includes the name of the student, ID of the student, his marks. So if you consider name is of character data type, ID is of integer data type, and marks is of float data type. Now, if you want to store such type of data where multiple data type values, if you want to store with a single variable name, then that can be done by using our structures concept. Array is defined as a homogeneous collection of data elements, whereas structure is defined as collection of heterogeneous data type elements. Heterogeneous is nothing but collection of different data type elements which are referred by using a single variable. Right? So by using a single variable, let us consider that variable is s. Now s is capable of holding, let us consider three values, and all these three values, this can be of int, and this can be of float, and this can be of character. So you can have three values of different combinations. But with arrays that is not possible. So using structure, which is one type of derived data type, which can be used to store multiple values of different data types, and all those multiple values can be referred by using our single name. Right, so the example for this one is real-time example is if you want to store a student information or a person information, then we can go with this structures concept. And what are all the values, what are all the data items we are referring, those data items are called as members of your structure, or they can also be called as fields of your structure. Like I am telling a student name, ID, and marks of the student. These three are referred as a members of that particular structure or fields of that particular structure. Now, whenever you want to create any structure, you need to create that structure by using a keyword called struct keyword. We have 32 keywords in our C programming language. One of them is struct. So whenever you want to use any design any structure, you need to use this keyword called struct. Now, what is the use of this one is, remember, whenever you want to store multiple values, you need to create one structure first, defining like this structure is capable of storing these types of values only. So that defining can be done, or that designing can be done by using this struct keyword. Right? The main advantage of storing using this structure is the accessibility of member variables becomes very easy. Like the structure gets allocated, whatever structure variable we are using, that will be allocated in continuous memory locations. Right? Suppose if you use three variables, one variable is to store the ID, other variable to store the one variable to store the ID, other variable to store the marks, and the other variable to store the name of the student, then it will be allocated somewhere else, it will be allocated somewhere else, and this will be allocated somewhere else. But if you are combining these three and giving a particular name called a structure name, then all these three values will be stored in a continuous memory location. Because of that, accessing these values will be a little bit faster when compared to the regular way. Right? So this is one advantage. So whenever you are working with the structure, let me tell you with variables, what we used to do with variables, first we need to declare that variable, and then we need to initialize that variable. Declaration is nothing but you will be telling the data type and name, right? Like you will be telling int a. This is called as declaration, and then assigning some value to this variable is called as initialization. So we have a two-step process in case of variables or arrays, like declaration, initialization. But whereas coming to the structures concept, we have a three-step process. That three-step process includes declaration, definition, and initialization. So what do you mean by declaration? Definition is, in this two-step process where you need to first design one structure. And what do you mean by designing the structure is, there in that structure you will be telling what is the name of this structure, and within that you will be telling like this structure is capable of storing let us consider four values, and data type of those four values is like this, like this, like this, we need to tell. So you need to design an overall structure in place of a declaration, and then by using this overall structure you can create variables that can be done in the definition part. Okay, so one more step has been added in the structure. So to do this task of declaration and definition, you have four ways. Any one of those four ways can be used. Let us see one by one. So before going to learn in the four ways in detail, you can see the difference between the fundamental data types and derived data types. Fundamental data types are your normal data, like primary data types, and using these primary data types we will be designing our derived data types, and our derived data types are pointers, arrays, structures and unions. We have already learned pointers and arrays. We are in the process of learning this structure. So you can make note of these differences between the fundamental data types and derived data types. So let us see the first way of structure declaration and definition. So in the first way, I already told you, whenever you want to work with structures, you need to first design the layout of the structure. Right? So that is called as a declaration of the structure. And whenever you are designing the layout of the structure, no memory will be allocated. And if you want to design the layout of the structure, this is the normal syntax you need to follow. First use the struct keyword and then use a tag name. This tag name can be any name following the identifier rules, and this can be made into one block, and within that you need to tell what type of data values you want to store. In case of array, all are of same data type, that's why we don't need to mention there. But whereas coming to structure, we have an option of storing multiple data type values. So you need to tell how many values you want to store, like variable 1, variable 2, variable 3, variable 4, like that. And you need to also tell what is the data of that variable also. So this is nothing but designing the overall layout of that structure. Now, whenever you are designing like this, no memory will be allocated. And remember one important point here, you need to end the designing, you need to end the declaration with a semicolon. Now, once you have designed the layout of the structure, you need to you can create multiple copies of this structure, and those copies are referred as variables. And whenever you are creating variables, then only memory will be allocated. So if you see how to create a variable like this. So once you define the structure like this, you can write struct tag, whatever tag name you use here, that tag name you need to use, and write in the variable names whatever you use. Let us consider a simple example. Let us consider you have designed struct, okay, and then you have designed student. STU is my structure name. Tag name is STU. Now within this structure, I want to have three variables. First variable is of name, okay. Second variable is of ID, and the third variable is of marks, okay. And name is of character, and ID is of integer. So we need to tell like this, and marks is of float. Okay, so if you have decided that like this, then by using this syntax, you can create struct, and then what is the tag name? Student. STU is our tag name, and I have created one S1 copy. And whenever you write like this, then for S1 you have three values. What are the three values? One is the name, the other one is the ID, and the other one is the marks. Got it? So with S1 we can store three values. So like this, if you want one more variable also, put a comma here, write S2. If you want one more, put a comma, write S3. So when you are creating the variables, these are called as variables. Whenever you are creating the variables, then only memory will be allocated. But at the time of designing the structure, no memory will be allocated. Okay, so one more thing you need to understand here is these are called as variables of the structure, and these are called as members or fields of your structure. Okay, so with our example, name, ID and marks are the fields of our structure STU, and S1, S2, S3 are called as variables of our structure STU. Okay, so this is the first way of declaring and defining a structure. The second way is where, observe here, way, struct, we have written the tag name, we have closed it here, and then we have another statement of defining the variables. But if you see here, I have combined both the declaration and definition, but I have removed the tag name. This is also possible. So what we have done here, we have written struct. I am writing the example struct, and within the brackets, I have not used any tag name here. Earlier we have used to write stu, but here we have not written anything. Simply write down the name, id, and the marks. You write down the data type also, char, okay, and then int, and then float. So you can write like this, and immediately without closing this one, you can write the variables whatever you want to create. Like this also you can do. This is the second method of designing this one, where tag name is not given. But here what is the problem with this one is, if you have created the number of variables, how many variables you want to create, you can create here only. But later on in the future statements, you can't create variables. So if you write like this, we are fixing like we want only two variables of this structure data type. But if you want to add one more, it is not possible in future. So in future we can't add, but with the first method we can add. After adding some more statements also you can add. Okay, so this is the second method, and we have a third method also, where if you want have an option of like here it is fixed, we can't add one more. But if you want to have an option of one more also, then we need to mention tag name also. That can be done by using a third type. See what we have done, we have combined the declaration and definition. Okay, and then we have written struct, and also a tag name is mentioned, and what are all the elements or members are required that we have defined here. Two variables are created initially. Later on, after some statements, we can add two. If you want, if you want, you can add other variables also. Right? So where tag name is mentioned. If tag name is not mentioned, at the time of declaration, definition should be finished also. Right? So with this, we can add in future whatever, how many variables we want, we can finish that one. Right? So this is the example which is depicting the three ways of whatever we have learned. But we have the other method also, where in this other method, I have used a keyword called typedef keyword. Remember, typedef is a user defined data type. In detail, we have not learned till now. But what is the use of this typedef in this case is, till now what we have written struct student and all the members we have written, and then we have written struct student s1 s2 like that. But here by using typedef, to this complete structure whatever we have here, for this a new name can be given. I am giving a new name, and from later on onwards this struct tag name can be referred with this new name whatever we give. That is the fourth method of declaring your structure, just renaming the structure. Right? So these are all the four methods that can be used to declare a structure and define a structure. Okay? And if you want to initialize the values, that means if you want to give some values to the structure members, then that can be done in two ways. One way is by using a dot operator, the other way is using the arrow operator. Using this want to use this arrow operator, we need to combine with the pointers concept that we'll be learning in our future classes. But in today's class, we'll see how to initialize the values of the structure using this dot operator itself. Okay, so let us see. So if you see here, whenever you want to use a dot operator to access the members of the structure or to initialize the values, that one, it's normal like dot operator like this we have in your keyboard, that is full stop symbol, that can be used to access. So how that can be done? First, let us take one structure defined like this. No memory will be allocated. One structure is designed like this. Now, normally if you see, it was suggested like whenever you are using any structures in your program, make that structure as a global. You all know what is nothing but a global declaration and a local declaration. Global declaration is nothing but that declaration, whatever you are doing, that can be used throughout the program. But local declaration is nothing but that can be used within the function where you have designed that, where you have declared that one. Right? Now, if you see this structure is defined, whenever you are working with structures, it is suggested like make it as a global. Even if you write as a local also, it is okay, no problem. But make it as a global, then it will be more advantageous. Now here you can see a structure student is designed, and it consists of three values. One is ID, the other one is name, and the other one is percentage. Now in the main method I have created one variable for this one. So this is the syntax. You all know how to do this one. Now what do you mean by this one? One variable called record has been designed, and this record will be having three values. Now what are the three values? One is ID, the other one is the name, and the other one is the percentage. Right. Now to give the values to this three elements, then how can we assign the values? You can assign the values by using the dot operator. Observe here. So how can you refer? Use the variable name, that is a record, put the dot operator, and then use the member element. So member is ID. So directly you can use the value. Now if you see for strings, we can't directly write the value. We have to use a strcpy, string handling function. So you have done that. Similarly, record dot percentage, directly it is a float value. We have directly assigned the value. Right. So this is how the dot operator we can assign the values. Here is a simple example. To understand this example, let us run one example. Okay. So initially what we need to do, we need to declare all the header files that are required in our program. Okay. I'm writing. Why I'm including stdio.h is to have scanf and printf option in our program, and then conio stands for hash include conio stands for console input output. And what is the use of this one is I want to have CLR feature in my program. CLR is nothing but clear the screen, which clears the output screen. Now I'm creating my structure. So struct keyword is used. Let me consider my structure tag name is student, and this consists of name, char name of 30. Okay, and then I think there is a spelling mistake here. Okay, and then int what is the other int ID. Okay, and then float marks. Okay, now you need to, and this is the structure we have designed. Our structure consists of three values of three different data types. Now I'm writing void main, and within the main I will be creating one member of this structure. So struct student. Yes, one first student I have created. Now to this yes student I want to give the name, ID and marks. So what I need to do, I need to ask the user to enter the values. So printf, or else directly let us give the values. So what is the first one? Name. So whenever you want to give name, remember for yes name is a string here. We can't write yes dot name equal to like this. This is not at all acceptable. Why? Because strings can't be assigned values like this. So how can we assign the values? We can assign the values by using string handling function strcpy. Okay, strcpy. And then you need to write what is the target, where you want to store, and then you need to mention the string whatever you want to store. Now whenever you are using strcpy, its header file should be included here. So let us include that one. Hash include string.h is the header file required for us. Okay, and after let me write clr why? Because I want to clear the screen once the old output I want to remove from my program. Now what is the next one? I want to write s dot id equal to, I want to give the id as 1 2 3, and s dot marks equal to, I want to give the marks as 78.9. Just okay. Now I want to print the details. I have assigned the values printers. I want to print the values student details. Okay, and then I want to print all the values one by one. So what is the first value? First value is name equal to, what is that one? That is string. So I need to write percentage yes, and where it is stored? It is stored in s dot name. Right. Next one is printf. What is that one? ID, and then ID is stored where? ID is stored in integer data type. So you need to use percentages s dot ID. Okay. Next one is printf. we need to get the marks, right? So marks, so it is stored in float value. So percentage F, S dot marks. So I hope you all are following this. So with this, we have printed this one, and this is the end of our main function. Understood all of you? So let us compile this program. Let us check any errors are there. No errors are there. So let us run this program, and we are expecting an output of student details, name, ID, marks. So if you see here, student details, name is given and ID is printed and marks are also printed. So this is how structure variable values can be initialized by using your dot operator. This is one way. Observe here, dot operator we have used. Okay. Got it, all of you? So practice this program, all of you. So this is how structure variable values can be initialized. This is the first way. How the first way is by using dot operator. Second way is using arrow, that we'll be learning while discussing the pointers concept, pointers and structure. Now here I have highlighted what are all the advantages of using the structure. Just if you want to store huge data, and if you want to have work with multiple data type values, then you can work with this structure. Okay, so with this we'll come to an end of our today's class, where how we have learned the introduction part to the structure. What actually a structure is, just note down the definition of the structure, all of you. Structure is a collection of heterogeneous data type elements that I have not mentioned in the slide. Note down the definition, all of you. And we learned how to define, declare and initialize the values of the structure. Initialization we have learned through dot operator. I hope you all are clear with this concept. Let us all meet in our next lecture. Until then, thank you all of you.